So the previous day, we had learned how to simplify radicals. And what I will say to you is, you need to know how to simplify radicals when you're doing this work. So for example, at some point in time, if you see the cube root of 54, which is in one of these questions somewhere, you need to be able to simplify that by either looking for perfect cubes, I don't know what that thing is, by looking for perfect cubes, or by writing the complete prime factorization of 54, which would be 54 is 9 times 6, 9 is 3 times 3, 6 is 3 times 2, which means since you have 3 3's here, they can come out because it's a cube root, and we can write 3 cube root 2. In the course of everything we learned about on Wednesday of last week, which was the last day we were here together, you need to continue to be able to simplify radicals. The bottom line when you're multiplying radicals together is that you multiply the coefficients with the coefficients and the radicands with the radicands. The reasoning for that is that if you had something like, I'm going to choose B. If you have, no, I'm going to choose A. If you have 2 root 5 times 7 root 3, 2 root 5 is simply 2 times root 5. And 7 root 3 is merely 7 times root 3. So you can think of it as simply being, you're multiplying 4 things together. The order that you multiply them in doesn't matter. So I can multiply the 2 and the 7 to get 14. I can multiply the 5 and the 3 to get root 15. So you would end up here with 14 root 15. Then you always need to make sure that you are checking the radicand that you produce to see if it can be simplified further. And root 15 doesn't break down at all. So take a look at your work, please. I know it's been a few days, but take a look at it and see if you have any questions. Go ahead, Lynette. 5C? Certainly. So we have 9, this one? 9 root 2m minus 4 root 6m quantity squared, which means it's 9 root 2m minus 4 root 6m times 9 root 2m minus 4 root 6m. I don't know too many people who could get C right in this particular question without rewriting it as the binomial times the binomial. Some of you might be able to. It's easy to make a mistake, though. So I'm going to be doing my first outer, inner, last deal. First means 9 root 2m times 9 root 2m, which will give me 81 root 4m squared. And I have to ask the question here, how many of you understand that the product of this and this, forgetting about the 9, how many of you understand that the product of those two things is 2m? Because we're multiplying the square root of a thing times the square root of a thing. If I say, what is the square root of 16 times the square root of 16? It's going to be 16. So we will be eventually walking into this territory where we might just write 2m here, but I'm not going to at this point. My outer is negative times positive, which will be negative, and I have 9 times 4, which is 36, and then I have root 2m times root 6m, which is root 12m squared. My inner is also going to be a negative. It's going to be negative 4 times 9, which is negative 36, and it will also be root 12m squared. And my last is negative times negative, which is positive. 4 times 4 is 16, root 36m squared. And if you wanted to, instead of writing root 36m squared, you could, of course, just write 6m. So now let's clean this up. This is 81 times 2m, because the square root of 4 is exactly 2, and the square root of m squared is exactly m. I have two similar terms here. I have negative 36 root 12m squareds, and another negative 36 root 12m squareds. That gives me negative 72 root 12m squareds. And I hope that when you eyeball this, that's your eyeball, that you see that we're going to be able to simplify that. My advice, I wouldn't do too much in one step. I wouldn't combine those two together and start to simplify root 12m squared. But, that's just me. And then over here we have 16 times 6m. This is 162m. This is, I think, 96m. Can somebody check my multiplication there on both of those? I think that's right. 6 times 16, 96? Okay. In the middle, what I'm going to do here, Lynette, and I guess you could just start putting these m's together right away, but I want to keep it line by line in my work. I'm going to rewrite this. Well, let's talk about that for a second. Root 12m squared. There are so many ways for you to arrive at this. Okay? Make sure that's right before I go on. And what I'm going to tell you right now is, you know what? I don't particularly care how you accomplish that. Okay? As long as you do it on your own, not, psst, what is it? I kind of combine methods here. I see an m squared underneath, so the m goes outside. And then what happened in my head is I'm kind of going root 12 is root 4, root 3. Lots of ways to write this. And root 4 is 2. So, the alternative, of course, is to do this. But I kind of think that's overkill for square roots of small things. You bring out the pair of 2's and write it as a single 2. You bring out a pair of m's and write it as a single m. Anyway, it's 2m root 3. And we are almost done. We can, of course, add the 162m and the 96m together to get what I believe is 258m, but I want confirmation on that. It is. And then this negative 72, Lynette, and this 2m are both coefficients. Basically, if it's not underneath the radical sign, then it's a coefficient. So I can multiply those together and get minus 144, I think, minus 144m. Nope. Minus 144m root 3. I forgot about my root 3 there. Is that okay? All right. Other questions? Yep. 2D. Okay. What we have in D, and I will rewrite D in a second, but what we have in D is a monomial multiplied by a trinomial. We have a single term multiplied by the sum of three terms. And that means we are going to have to multiply that way. It's not FOIL, but it's the distributive property. So I do want to rewrite this just so you can see it. It never really occurred to me until just this minute that maybe this is advice I should be giving you. When things are typed up on a computer, so on an exam, particularly with radicals, everything is really close together. And visually, I think sometimes you look at it and you're confused by what it means. So my advice to everybody is, if that's the case, then rewrite it and just kind of space things out a bit. But that's what we have to simplify. Now, Kendra pointed out in an example, I believe, on Wednesday, that sometimes you can simplify stuff first before you multiply it out. Was that you that? Yeah. And sometimes it's quicker one way, and sometimes it's quicker the other way. I do have a root 12 here. And root 12 can be simplified. So then you have to make a decision. Do you want to simplify the root 12 first? And in my mind, I wouldn't in this case, only because I can see when I multiply this out, I'm going to get root 3 times root 12, which is root 36, which is 6. So I'm not saying you would be wasting your time by simplifying root 12, but you're going to discover that it's quicker not to. Would you, when you tried this, did you do the root 12 first? You multiply it through. Okay, so let's multiply it through. I get z times z. Those are both coefficients, which is z squared, root 36, because root 3 times root 12 is root of 3 times 12. I multiply the z root 3 times the negative 5z. This is a coefficient, and this is a coefficient, so we multiply them. And we're left with a radicand, or a radical rather, of root 3. And then z root 3 times 2 is 2z root 3. Again, I'm multiplying coefficients. I'm multiplying the z as a coefficient and the 2 as a coefficient. You see, that's why I cross my z's, so that I don't confuse them with 2's. And even though the z is written first, I would probably write 2z. Now what I can do, I notice a couple of things here, is I can simplify root 36 to 6 and get 6z squared. Now I have a bit of a problem. I mean, I literally have a problem as a teacher here, which is part of me wants to say that this is the answer. But part of me also wants to recognize that it may not be the answer. Okay? And the reason is, this is a little bit screwy to think about, but those two terms at the end are multiples of root 3. It's not as simple as saying I have 12 root 3 and another 7 root 3. I can't just add 12 and 7. That's pretty easy. But here, it's pretty complicated. But what you could do is you could say that I have negative 5z squared plus 2z root 3's. Like if this were 7 root 3 and 5 root 3, you'd add 5 and 7 together to get 12 root 3. So that's what I've done there. But I really believe that this, at this level right now, at this stage of the game, that should be the answer. You okay with that? Okay. Any other questions before we move on today? Okay. So we're going to move on to part 2 of this section. Which deals with dividing radical expressions. And I know that it says here we're going to be dividing monomial rational expressions. I realize that's an error because we are going to be dividing other ones as well. So this is on page 6 of your unit handout. We're also going to be doing something called rationalizing the denominator. So I want to start off and just explain to you what that means in terms of the word rationalize. Root 6 is not rational. That doesn't mean, It's not like rational in English. If you're dealing with a rational person, they're level-headed and they're reasonable. That's not what I'm talking about. Root 6 is an irrational number because it's the square root of a non-perfect square. However, something like 12 is rational. And don't draw a connection here between the root 6 and the 12. They're just two separate things. My point is that if there's no radical, it's rational. So when we talk about rationalizing the denominator, what that means is to rewrite any denominators that have radicals as denominators that don't have radicals. Rationalize means to remove the radical. Because if there's a radical, it's not rational. So it should come as no great surprise to you that the general rule we used for multiplying radicals is the same as the one we use for dividing. You are allowed to multiply coefficients, and that means you are allowed to divide coefficients. Coefficients can be divided by coefficients, and since we can multiply radicals together by multiplying the radicands, we are allowed to divide radicals by dividing the radicands. And they have to have the same index. In other words, if I gave you something along the lines of this, cube root of 148 over the square root of 18, there is nothing you can do with that to simplify it in that form. They have different indices. One is a cube root, one is a square root. Now, could you potentially move numbers outside and have a coefficient on the top and a coefficient on the bottom? Maybe. Then you could divide coefficients with coefficients. Let's look at this in action. Start off with something very simple. Root 960 over root 120. What I am telling you, everybody, is that when I say you divide radicands, I'm saying root 960 over root 120 is the same as the square root of 960 over 120. Now, does 960 divide by 120? Nicely. Meaning, does it divide into a whole number? Guessing 8? Oh, okay. So this is equal to root 8. Of course, we know, and you're going to have to get more and more used to this, that in this unit, when you're dealing with radicals, when you think you're done, go back to the beginning and start looking at simplifying where you're at. So one of the things we learned in the beginning is how do you simplify something like root 8? Well, root 8 is root 4, root 2, and root 4 is 2, so it's 2 root 2. And I hope, maybe by a show of hands, nod of the head, how many of you just know root 8 is 2 root 2 by this point? You write it. You've seen it so many times, right? You might just for a split second go, oh yeah, 4 and 2, so 2 root 2. But we're done. Negative 7 root 256 over 14 root 32. So what we're saying here when I say you're dividing coefficients, and things will get more complicated, definitely, is that, let me rewrite it, negative 7 root 256 over 14 root 32. I really dislike that, I call it a hanging negative, that negative that's out in front of the whole thing. Put it somewhere. Put it on the top, put it on the bottom. So when I say we divide coefficients with coefficients, I'm saying that what we're going to be doing is this. We're going to write negative 7 over 14 and root 256 over 32. We're dividing coefficients with coefficients. Now, we have to be a little more sophisticated than a grade 7 or 8 student who learns that when you divide, you can get a decimal. We don't want decimals. We want to say what is 7 divided by 14 as a fraction in lowest terms, and it's 1/2. And you should not be using your calculator to determine that 7 over 14 is a half. If you do, you're going to get really lost in the next unit. So we end up with negative 1 over 2. I still like the negative on the top. And then we say, does 256 divide by 32? 7? No. 8. 8 again. Wow. Look where I wrote that root 8. What's actually happening here, everybody, and I want you to see this, is we have root 256 over 32. That's root 8 over 1. 256 over 32 reduces to 8 over 1, which means it's root 8 over root 1. We don't write over root 1, but it's important for you to understand the root 8 is on the top. I am really curious here. How many of you see that this is equal to negative root 2? Okay, because you're not done. You have the negative 1 over 2, and then you have to simplify root 8. Well, root 8 is root 4 root 2, which is 2 root 2. And again, look where I wrote that. It's not perfect, but that 2 root 2 is on the top. So I have a factor of 2 on the top, a factor of 2 on the bottom. I can cancel them, and I'm left with negative 1 root 2, which I would just write as negative root 2. Okay with that example? All right. Now, by the way, I believe we were asked here about restrictions. So in C, we're taking the square root of a variable raised to an odd exponent, which means that that variable needs to be greater than 0. Two things, and these might seem to you as being picky things, but first of all, you find your restrictions before you simplify. I don't care if all the r's cancel. If there's r in the original expression, you have to look at that original expression for the restrictions. Secondly, I forgot what my secondly was. Give me a second. Oh, can somebody tell me why I didn't write this? I actually did, and then I erased it. Because I taught you that the radicand has to be greater than or equal to 0. Why did I just put greater than? Yep.
Isn't that because if r would be 0, then your answer would just be 0 and it wouldn't be a value for what's actually there?
No. If r were 0, the expression would not actually be equal to 0. It would be equal to something else, Brody.
Oh, you can't divide by 0.
Can't divide by 0. Because there's an r in the denominator radical, if r were 0, then you would be dividing by 0, which is not allowed. So what we would do is we would say normally the variable or the radicand that contains the variable has to be greater than or equal to 0 unless you're also dividing by it. And then you can't have it equal to 0 because division by 0 is verboten. You can't do it. So that's the restriction. Would you agree 80 over 15? Oh, 80 over 15 is not a whole number, is it? Here's what my mind is automatically doing. 80 over 15, I'm saying that's 40. No, it doesn't divide. I guess divide by 5 is 16 over 3. I mean, I know you have a calculator. You could figure that out, but you should understand how I'm getting 16 over 3. I'm dividing the top and the bottom each by 5. And what I'm really doing, I hate to drag this very far off of our path today, but what I'm really doing, everybody, and this is crucial for the next unit, is I'm recognizing that 80 is 5 times 16, and 15 is 5 times 3. See all those brackets? That means anything in brackets is a factor. There's a factor of 5 on the top and a factor of 16 on the top. There's a factor of 5 on the bottom and 3 on the bottom. You were only ever allowed, and I'll say this a dozen more times, 3 or 4 dozen more times in this course, you are only ever allowed to cancel something if it's a factor on the top and the bottom. Okay. So anyway, that's 16 over 3. Okay, we get 16 on the top, 3 on the bottom. I guess what we could do, you could do this on the side, but I'm just going to write 432r to the 5 over 72r cubed. Does 72 go without remainder into 432? That's 6. Okay. So this becomes 16/3, and its root 6 over 1. You don't have to write that over 1. You really don't. But I want to stress that what we're going to get, which is going to be this thing, will be on the top of the fraction. It's not just something. It's the top. It's over 1. And r to the 5 over r cubed is r squared. Right? You subtract the exponents, or, I mean, I hope you don't have to do this. I hope you don't have to do that to see it's r squared. So we certainly don't need to write over 1. And, to boot, since we have a root r squared, the square root of r squared is simply r, or if you like, we've got r times r under the square root, becomes a single r outside of the square root. Any questions with that example? This might be written this way, right? Even though I like to keep the coefficients separate from the radicals, it could be written that way. Okay. Rationalizing a denominator. So to simplify an expression that has a radical in the denominator, you are expected to rationalize the denominator. So from here on in, until you get to calculus, if you take calculus, that's the rule. No radicals in the bottom, ever. So how do you do that? You multiply the top and the bottom of the expression by the radical. So you need you to pay attention up here, please, because what I'm going to show you is not in your notes. I'm going to multiply the top and the bottom of an expression that contains a radical in the bottom by that radical. So for example, if I had 5 over 2 root 3, for some reason that's really not important at all, we don't want radicals in the bottom. And lo and behold, there's a root 3 in the bottom. So how do I get rid of it? I multiply the top and the bottom by root 3. Can somebody explain to me why, by doing that, I'm not changing the value of the expression? Because 5 over 2 root 3 has a certain value. I'm going to show it to you. Five divided by, I better put the 2 root 3 in brackets because it's two things multiplied together. 2 root 3. This is what 5 over 2 root 3 is equal to. And I'm saying I'm going to multiply that by root 3 over 3 times root 3 divided by root 3. Why can I get away with that and not change the value of the number? Because I can't take that number and multiply by 12. That'll change the value of the number. Why am I allowed to do what I just did on the board? I'll ask a different question. What's special about root 3 over root 3? It's 1. Right? Root 3 over root 3 is 1. So I'm multiplying by 1. Whatever I do the top of an expression as a fraction, I have to do to the bottom. So what do I get here? When I multiply fractions, I multiply across the top and I multiply across the bottom. I get 5 times root 3 over 2 times root 3 times root 3. But now on the bottom, I have root 3 times root 3, which is root 9. I didn't show this, but this is root 9, isn't it? Because 3 times 3 is 9. And the square root of 9 is 3. So I'm left with 2 times 3, which gives me 6, and now it's rationalized. There's no radical in the denominator. And by the way, root 3 times root 3 is 3. Can you confirm that on your calculator? Can you take the square root of 3 times the square root of 3 for me, please? Yes? Okay, don't jump to your calculator just yet. I want you to figure out. What the square root of 1258 times the square root of 1258 is. I hope you're not going to use your calculator. It's 1258. The point is that root x times root x is x. And that's something we're going to be using a lot of. Okay, so simplify each expression. There are so many different things we can do here. Okay, first of all, I see root 20 and I think, you know what? I'm pretty sure root 20 can be simplified. And before I dive into rationalizing anything, I'm going to break root 20 up into root 4, root 5, which means root 20 is 2 root 5. I'm a huge fan of simplifying a radical off on the side. I think it's more economical and it's less cluttered with your workspace. So this becomes 30 over 2 root 5. Hey, wait a minute. Is 30 a coefficient in this expression? Is 2 a coefficient? So we can divide 30 over 2. It's 15. So now we're at 15 over root 5. Are we done? Well, we can't simplify any radical anymore, but we're not allowed to have a radical in the denominator. And you will never be told that from now on. You have to know. So how am I going to get rid of the root 5 in the denominator? I'm going to multiply the numerator by root 5 and the denominator by root 5 and get on the top. There's nothing I can do with 15 times root 5 other than to write 15 times root 5 over 5. The square root of 5 times the square root of 5 is 5. If you need to write root 5 times root 5 is root 25 and then change it to 5, that's fine, but it's 5. Are we okay with that step? This is the weird stuff. It's like a never-ending cycle. We simplified a radical, we divided some coefficients, we rationalized the denominator, and out of nowhere comes 2 more coefficients that I can divide. 15 is a coefficient and so is 5, so 15 over 5 is 3, and we end up with 3 root 5. We went from 30 over root 20 to 3 root 5. Just to check this out, 30 divided by root 20, 6.7 something, 3 root 5. It's the same thing. But it carries with it all of the conditions that we need in an answer. The radical is as simple as possible. All coefficients have been divided with all coefficients. All radicands have been divided with all radicands. And you have no radicals in the denominator. Those are the conditions. Root 60 x to the 8 over root 75 x to the 5. So, okay. This can be written as the square root of 60 x to the 8 over 75 x to the 5. And I believe, everybody, that if you were to go back and look at question 1, it's very similar to this, isn't it? Except when we divide, and there's no variables, but when we divided these, it worked out to 8. Exactly 8. When we divide these, 60 doesn't divide by 75. But we can reduce 60 over 75 down to lowest terms. Please, I want you trying to think about this and using your head as much as possible. 60 over 75, these numbers are both divisible by 5. So if I divide the top by 5, I get 12. If I divide the bottom by 5, I believe I get 15. These numbers still have a common factor. Go ahead.
60 and 75 are also both divisible by 15.
Yeah, and we could have done that to begin with, definitely. You could have said divide by 15, divide by 15, definitely. If you do it in stages, we would get to here, and I want to stress that you're always looking to see, can you simplify it, can you push it further? And 12 over 15 reduces by a factor of 3, which gives you 4/5. And by the way, again, I'm going to mention it for the second time just today. You only ever cancel something that's a common factor. So the reason why Seamus was able to do this was because 60 is 15 times 4, 75 is 15 times 3, no, times 5. So Seamus is seeing a factor of 15 on the top and the bottom, which cancels. That's why it works. Anyway, we end up with 4/5, and that means we have a 4 in the numerator of our radicand, and we have a 5 in the denominator, and x to the 8. So all this stuff that I'm just erasing right now, you don't need to show that. You don't need to show how you go from 60 75ths to 4/5. X to the 8 divided by x to the 5 is x to the 3. Okay. It's x to the 3 over 1. So the x to the 3 is on the top. Okay, so now that we've simplified that, and you know what, let me write this next thing first. Now that we've simplified it, we're going to actually go backwards and write 4x cubed as a radicand over 5 as a radicand. And I would say to you that you can certainly go from here to here. You don't have to rewrite it as a single radical, which is the middle line. You could just simplify things that way. Okay, so now what? Let's go over here. Well, the square root of 4 is 2. That's pretty easy. And the square root of x cubed is x root x. Because root x cubed is root x times x times x, which is root xx times root x. Root xx is just x, root x. Over root 5. So let's do a check here. Can you simplify root x? No. Can you simplify root 5? No. Can you divide x by 5 to get a simpler fraction? No. But we're not done because you're not allowed a radical in the denominator. So you have to multiply the top and the bottom of this expression, the numerator and denominator, by the square root of 5. Root 5 over root 5 is just 1, so you're not really doing anything to change the expression. So what do we get? We get 2x on the top. We get root 5x on the top because we have a root x times a root 5. And then on the bottom, we have root 5 times root 5, which is 5. And that's it. Are any radicals removed from the denominator? Yes. Is there any coefficient that can be simplified with a coefficient? Well, I do have coefficients on the top and the bottom. 2x is a coefficient, so is 5. But 2 over 5 doesn't reduce. Are any radicals that are there simplifiable? Can you simplify root 5x? No. All right. C. Well, let's just rewrite this as negative 5 root 5 over 8 root 7r. Of all of the things I've talked about, dividing coefficients with coefficients, dividing radicals with radicals, simplifying radicals, and getting rid of denominators that have radicals, I hope you see there's only one problem here. There's nothing that simplifies in each of the radicals. The coefficient of 5 over 8 doesn't reduce. The radical fraction of root 5 over root 7r doesn't reduce, but we got a root in the bottom. So I have to multiply top and bottom by root 7r. Notice, by the way, I don't include the 8. You could, it'd just make more work for you though. So what do we get? On the top we get negative 5 root 35r, 5 times 7 is 35, over 8 times 7r, because root 7r times root 7r is 7r. A root times a root cancels if they're identical radicands. So I get negative 5 root 35r over 56r. Okay, can these two coefficients be whittled down to smaller numbers? No. Is this radical simplifiable? Like, is there a perfect square as part of 35r? No. So we're done. No radicals in the bottom. Okay, simplify each expression. I don't know when this happens, but I suspect many of you it has already happened to. You look at root 40, you know it's simplifiable. You look at root 20, you know it's simplifiable. Just put your pencil down for a second. And I could have done this earlier with a different example. Let's say that you said, you know what, I am going to, Mr. Way said I don't want radicals in the denominator, so I'm going to multiply top and bottom by root 20. By the way, when we do this to the top, we need a set of brackets there. You're not writing this down. So then on the top, what do we get? We get root 20 times 14. And then minus root 40 times root 20 is root 800 over root 20 times root 20, which is 20. Does that make sense to you? Do you follow that step? Okay, so now let's take a look at, now pencils back. We're going to write this down now. I'll come back to this. Let's take a look at simplifying this first. Root 40 is root 4 root 10. So this is 2 root 10. Over root 20, this is kind of my scrap paper, is root 2 root 5. Nope. Is root 4 root 5, which is 2 root 5. So let's just pause for a second. All I did was I simplified root 40, and I wrote in the result, and I simplified root 20, and I wrote in the result. Can I do this? So before you do it, don't write it, because I don't know if the answer is yes or not. Am I allowed to do this? Those are coefficients. Well, the answer is no, I'm not allowed to do that. The question then becomes why? And I've already told you why twice today. You were only ever allowed to cancel something if it's a factor on the top and the bottom. 2, this 2 that I canceled on the top, is not a factor of the top, because something that is a factor of the top would be in brackets times other stuff on the top. This minus inside screws up the whole factor thing. But can I factor a 2 out of the top? There's a factor of 2 in 14. and there's a factor of 2 and 2 root 10. So now, are those two 2's factors? Yes. And we end up with, we're not done yet, we end up with 7 minus root 10 over root 5. How many of you, by a show of hands, see a similarity between what we did to go from here to here and simplifying the quadratic formula? It's the same idea, right? You just have to make sure you cancel the same thing out of each term on the top and out of the term on the bottom. So now I'm pretty much done, except I have to rationalize that denominator. I need to multiply top and bottom by root 5. So I'm going to get 7 root 5 minus root 50. Root 10 times root 5 is root 50 over 5. And although that may seem like more work than what we did here, which I didn't want you to write down, the numbers here are really big in comparison. So simplifying root 800, it's not a Herculean task. It's not this monumental task that you can't do. But wouldn't you rather simplify root 50 than root 800? All right, so 7 root 5 minus 5 root 2. Don't just blindly write that down and go, oh, he said it's 5 root 2. It must be 5 root 2. What have I done? Root 50 is root 25, root 2, and root 25 is 5. Again, one of these ones that I think, even though the number is 50, I think coming up with 5 root 2 from it is pretty simple. And this is over 5. No. Yes? Can I do that? No, I can't. 5 is not a factor of the top. Now, if this 7 were a 15, then I could start whittling it down. So this is it. We're done. 7 root 5 minus 5 root 2 over 5. One more example. 3 root 6 plus 12 all over root 18. By the way, you decided to take this path on the right for question 3a. You'll get there. Still get you the right answer. Oh man, I see root 18. I'm thinking, let's simplify that first. I do not want to multiply top and bottom by root 18. Root 18 is 3 root 2, I believe. Root 9 root 2, which is 3 root 2. How many of you see a very nice thing is about to happen with this expression? I've got a common factor of 3 on the top and the bottom. Please pay careful attention to the explanation I'm going to give you here. This has got to be the 4th or 5th time today I'm talking about canceling factors. Okay, and if I'm doing it that often, it's really, really important. I know that some of you will want to just write root 6 plus 4 over root 2. And that's correct, okay? And what you're doing, I don't like seeing this. I really don't like that. Don't do that. That's going to cause problems later. But that's what you're really doing in your head. However, the reason that works is because I can take a 3 out of the numerator, common factor of 3. I can, well, I'm not really taking a 3 out of the denominator, but the bottom line is I have a factor of 3 on the top and the bottom. That's why that works. Okay. I'm going to multiply top and bottom by root 2. So I get, distributing this root 2, I get root 12 plus 4 root 2 over 2. is like zombie math. Every time you think you're done, it rises again, and you have more work to do. You know, I thought we simplified all the radicals, right? Root 18 was 3 root 2. Now all of a sudden we have root 12. Well, what's root 12? Again, I'm a fan of doing this on the side. This is root 4 root 3, which is 2 root 3. So I am going to be writing, instead of root 12, 2 root 3 plus 4 root 2 over 2. And again, I thought we canceled all the coefficients we could, but now we can cancel again, because I can factor a 2 out of the top and be left with root 3 plus 2 root 2 all over 2. 2's cancel. So root 3 plus 2 root 2 is the answer. Briefly, I realized that I didn't talk about variables. Here, r would have to be greater than 0. Can't be negative because you can't take the square root of a negative. And it can't be 0 because you're dividing by root of that. X must be greater than 0. I want you to just pay attention to this for a second. Even if the x's canceled, which they don't, the fact that you have x to an odd number under a radical in the denominator tells you it's not going to be 0 or positive or negative. It has to be greater than 0. I think that was it. By the way, for 3c, you can feel free to do that one if you like. But it's the same as 2a or b or c. We already did it. So there's a bunch of practice on the next page. I think it's page 8 of your unit handout, where you are rationalizing denominators, dividing radicals, dividing coefficients, and you know you're done when your checklist is complete. All radicals simplified. Coefficients reduced with coefficients. Radicals reduced with radicals. And no radicals in the denominator. So get to work on that practice. I need to just take attendance and take care of something at my computer, and then I'll be around to help you out. You still have about 20 minutes here to work on this today.